going to study right circular cone as per NCERT syllabus for class 9. We will be discussing right circular cone. Whenever we hear about cone, the first thing that comes into mind is that of the ice cream cone. So the structure looks like ice cream cone only. This is the structure of a right circular cone. This is called right circular cone. This is right circular cone. Why right circular cone? The base is circular. The base is circular and the line joining this vertex to this line, base line, is perpendicular. That is why it is called right circular cone. And we will be studying only right circular cone. So we are interested in this figure where line drawn from vertex to base is perpendicular and the base is circular. This is a truncated circle, and when I join the ends, I get a structure like this, where this is circular and this is a structure of a cone. Now, how does it form? This is a right angle triangle. Right angle at this place. Suppose I keep this point here and fix this end, these two ends, fix these two ends and rotate it on this side, then the structure formed by the figure, the shape formed by this movement of this triangle gives the structure of a cone. Ice cream cone. We can visualize and understand this. This cone, all of us have seen, is formed from this. These two ends were joined together side by side to make a cone. These two ends, A and B, were joined together to make a cone. When I open up, this gives a figure of a circle. Suppose I divide it into smaller triangles. Very small triangles. Like this OB, this B1, this O, B1, B2, and suppose this is B1, B2, B3, B4, B5, and so on and so forth, so that this triangle completes this circle, part of this circle. So in this case, we are able to see that these triangles, the area of these triangles will, up to this point A, will give, if I divide this into a smaller triangles, then, and when I add up these areas, then I am able to get this curved surface area. So, what will be the curved surface area? Sum of the area of all such triangles, that is half B1, this B1 into this. This is, in case of, it is also important for us to understand this figure. Here this base, this is radius R, this is L, slant height from this to this place, and this is H, from this place to this place, height of this cone. So here this will be, for for this smaller triangle B1 into L. Similarly, B2 into L. Similarly, half B3 into L. And it goes up to this point. Suppose here it is half Bn into L. So, upon adding this half L common, B1 plus B2 dash dash Bn. What is this? B1, B2, B3, B4, B5, B6, B7 and Bn. This is the circumference. And what is the circumference? Circumference of a circle? 2 pi r. So this is pi r L. So curved surface area, this curved surface area of right circular cone. Now we know this curved surface area of right circular cone is equal to pi r L. Now again it is important for us to understand this thing. This is, suppose this is the structure of a cone. Okay, this height is h, this is r, the circular base, radius of circular base is r, and this is called slant height L. So what will be this, suppose this point is A, this is B and this is C, then in triangle ABC just we have discussed that a line drawn from vertex to base is perpendicular in case of right circular cone. So ABC is a right angle triangle. So in that case, from Pythagoras theorem we know this is the hypotenuse. So hypotenuse square is equal to perpendicular square plus base square. So L is under root h square plus r square. This figure and this thing we should also remember. So now we have we know curved surface area and what is slant height, what is base radius and what is height of a right circular cone. Now the other thing to know is total surface area. In case of other figures also we had been calculating curved surface area and total surface area. In case of this, for calculating total surface area, now we know the curved surface area. This is the curved surface area. Then apart from this, there is a circular base at the circular base. This circular base, what is the area of a circle? Pi r square. So once we add up this area of this base also into this curved surface area, we get the total surface area. So what will be the total surface area? Total surface area, here only I am writing in place of curved, if it is total surface area, total surface area of right circular cone. This is curved surface and plus this pi r square, area of circle. Area of circle is added in curved surface area to make it total surface area. We can write it in, if we take out pi r as common, this is L plus r. In this way also we can write, in this way also we can write. It hardly matters. the way we write, it is up to us to how better we understand thing, we should write in that way only. Now that these are the only two things which we need to study and understand, all the question pertaining to this NCERT Class 9 syllabus for this right circular cone comes under exercise 13.3. So, based on this information only, we will be able to solve all the problems of this exercise 13.3. Now, coming to solving of problem. Now, coming to solving the problems of exercise 13.3 of Class 9 NCERT Maths book. The first question. Diameter of the base of a cone is 10.5 centimeter and its slant height is 10 centimeter. Find its curved surface area. Although this we know diameter of base is given, so radius of the base is given. Slant height, just we have studied L, that is also given, and we need to find out curved surface area. We know the formula of curved surface area, that is pi RL. So pi we will be taking 22 upon 7 as per the assumption given in the book, and then R is given, L is given, so it is easy for us to do based on formula only. But for better clarity, let us have a picture also so that we know the things well. This is R, here this is D by 2, and accordingly this is 10.5 by 2 centimeter. This is R. From this point to this point, the radius of the base, and this is diameter divided by 2. This is 10.5 divided by 2 centimeter as per the value given in question. This is H and this is L. This L is also given. L is given as slant height is written. So this is slant height and this is the vertical height. So slant height is given at 10 centimeter. And we need to find out the curved surface area. And we know the formula for doing this. We get curved surface area by pi RL. So putting the values 22 upon 7 in place of R, 10.5 divided by 2, and in place of L, this is 10. This is 1.5, 7 1 is 7 and 7 5 is 35. This is 5. So this is 22 into 7.5, and upon calculating we will get 165 centimeter square. And this is about the first question. Now coming to the second question of exercise 13.2 of class 9 NCERT Maths book. Second question, find the total surface area of a cone if its slant height is 21 meter and diameter of base is 24 meter. Here also we see slant height L is given, diameter of base we will be dealing in all the formulas with the radius. So diameter is given, so radius is given. So everything is given and we need to put the values in the formula and we will be getting it, but it is better that we first construct a cone and see things and then do. That will be the better thing for us to do. In that case, the chances of mistake is not there. Here slant height, we call this slant height, This is given as 21 meter. 21 meter. This slant height from this place to this place is given as 21 meter. Diameter of base. Diameter is this and this is R. So R is equal to D upon 2. That is, here diameter is given. So this is 21 by 2 meter. This is also okay, 21. Diameter is 24. Diameter is 24. So this is 24 upon 2. Diameter of its base is 24 meter. So radius is 24 upon 2. Now, what is to be find out? Total surface area. What is TSA? We know TSA is pi R plus L. Value of R is given. Value of L is given. Pi we will be taking 22 upon 7. So everything is given. So I don't think there is any problem doing this. 24 by 2, that is 12, and this is 12 plus 21. So this is 22 by 7 into 12 into 33, and upon multiplying and dividing we will get it as 1244.57 meter square. So now it is, I think, clear. Now coming to the third question of class 9 NCERT exercise 13.3. Third question. Curved surface area of a cone is 308 centimeters square and its slant height is 14 centimeter. Find the radius of the base and total surface area of the cone. In first question, curved surface area was to be calculated. Diameter and slant height was given. Here, curved surface area is given and height is given. We need to find out the radius. So, in every case, we need to make a figure so that we do not make any mistake while calculating. This is H, this is R, this is L. Curved surface area of this is given as 308 centimeter square. Then the slant height L is also given. This L from this place to this place, L is given as 14 centimeter. What we need to find out? First thing is to find out R, this radius of the base. Curved surface area is given, L is given, R we have to find out. We know that the CSA is how much? Pi R L. We have to find out R. So R is how much? CSA upon pi. So we need to find out R. Curved surface area is given. So CSA, we know CSA is equal to pi R into L. So we need to find out R. So what is R? R is equal to CSA upon pi L. What is CSA? 308 and upon 22 by 7 for pi, and L is 14. 7 2 is 14. So this is 2154 and this is 7 times. So this is 7 centimeter. So R we will get at 7 centimeter. Everything was given. for CSA, and CSA was given, L was given, we need to find out R, and we put the values in the formula for CSA and we got this R as 7 cm. Now coming to the second part of the question. What the second part says? Second part, we need to find out the TSA. Now we have calculated R also 7 cm from first part, and now we need to find out TSA. We need the formula for this, pi r L plus R. So pi 22/7, R 7, just we have calculated in first part, L that is given in question as 14. So we will put the value of pi as 22/7, R is equal to 7, just calculated, L is equal to 14, and this R is equal to 7, and this is 22 into 21, and we get this as 462 centimeter square. So this is about the third question, second part. Now the fourth question of exercise 13.3. A conical tent is 10 meter high and the radius of its base is 24 meter. Find slant height of the tent. First part. Second part, cost of the canvas required to make the tent if the cost of 1 meter square canvas is rupees 70. Again we will be making a right circular cone for better understanding and no mistake. This H is given as 10 meter, then this radius is given 24 meter, R is equal to 24 meter. First part is we need to find out the slant height, this L, this is the slant height, and we know from Pythagoras theorem L is equal to under root h square plus r square, h square plus r square. So here putting value of h, so this is 10 square plus 24 square, so this is 100 plus 576 under root 676, and this is 26 meter. So slant height is 26 meter. First part is about slant height, and slant height is calculated from this right angle triangle. We know this is right circular cone, so this forms a right angle triangle. This square is equal to this square plus this square. So L is equal to under root h square plus r square. We have put all the values and we got the value of L. So L now we know as 26 meter. Now coming to the second part. What is that second part? Second part says cost of canvas required to make the tent if cost of 1 meter square is rupees 70. So cost of canvas. So cost of canvas means this curved surface area. So we need to find out CSA, pi r L. So 22 upon 7 into 24 into 26, and on multiplying we get 13728 divided by 7 meter square. This CSA we have calculated from formula. We have put the value of R and L which we calculated in first part. Now what is the cost of making that tent if the canvas comes at rupees 70 per meter square? if 1 meter square of canvas comes at rupees 70, what will be the cost of making it? So the cost will be, for 1 meter square it is 70. So for this much meter square we need to multiply it by the cost rate, that is 70. So this is 10 and we get 137280. This much rupees is required. So this is about the fourth question of exercise 13.3. What length of tarpaulin 3 meter wide will be required to make a conical tent of height 8 meter and base radius 6 meter? Assume that the extra length of material that will be required for stitching margins and wastage in cutting is approximately 20 centimeter. We are making a cone. First, to show the dimensions, and then we will proceed as a standard. So first we are writing down what is given. Conical tent of height 8 meter. So this h is equal to 8 meter. Okay. Base radius 6 meter. This r is also given as 6 meter. Okay. This conical tent of you see there is another dimension, that is what length of tarpaulin 3 meter wide will be required to make conical tent of height 8 meter and base radius 6 meter. So what is given about this conical tent, we should first see this. And what is written about this tarpaulin 3 meter wide is about that sheet of tarpaulin which has got length and breadth. So its breadth is given, this is 3 meter wide, and what length of that tarpaulin we want to purchase, that we have to find out. But first we should look and see what is this figure, what is our cone, and what is the measurement of this conical tent. So first conical tent we need to see. So this is conical tent, height is given, r is given, but the slant height is not given. So we need to find out. So we know that this is h square under root h square plus r square. So this is under root 8 square plus 6 square, and this will come as 10 meter. So now this is also known, this is 10 meter. Now coming to the question. Assume that the extra length of material that will be required for stitching margin and wastage in cutting is approximately 20 centimeter. Tarpaulin sheet, whenever you visit any clothes shop, you get clothes as you need, as per your need, like 1 meter, 2 meter, 3 meter, 5 meter, 6 meter, and the clothes are having some width. So here that tarpaulin is also a kind of cloth from which tent is to be made, and the width part, how much wide is given, but length part we have to find out. How much length we need to purchase to make this conical tent. This is important to understand. And 20 centimeter of the length is wastage in stitching. So in stitching part also some material goes waste because one thing is overlapping other. Then there are some cut and waste uses, etc. For that 20 centimeter length is required, that is written, that is given. So this L we know. So the tarpaulin will make this tent. So this curved surface we need to find out, because that tarpaulin will make this curved surface. So what is CSA? CSA will be pi RL. So here it is written that we should take it as 3.14. Pi should be 3.14 into R. R is 6 into L, this 10. So we have taken this, and how much this comes? This comes as 188.4 meter square, because it's area, so the unit is meter square. So CSA, this curved surface area we know, and this curved surface area will be made from that tarpaulin sheet, and that tarpaulin sheet width is given, and it is given that we need to purchase in such a way that 20 centimeter will go waste. So let us assume that the tarpaulin sheet, about that tarpaulin sheet, it is given that it is 3 meter wide, and let us assume that we purchase L meter. But if we purchase L meter, 20 centimeter will go waste. So actually we will be using L minus 0.2, because 20 centimeter I am making it in meter, so that both are. So this length, actual length that will be used for making this area of 184.4 meter square CSA will be L minus 0.2, because 0.2 will go waste in stitching. So what is this area of this tarpaulin should equal to this CSA. So L minus 0.2 into B, L into B, this area of this tarpaulin sheet should be equal to 184.4, and we need to find out L, which comes out at 63 meter. Upon solving, we will get, this is just simply, this is not a very great thing to do. 3 will multiply here, 3 will multiply here, this will go there, so that will be added up, then this 3L, so 3 will go there and it will be divisor, and we will get the length of the tarpaulin at 63 meter. This is all about 5th question. Now coming to the 6th question of exercise 13.3. The slant height and base diameter of conical tomb is 25 meter and 14 meter respectively. Find the cost of whitewashing its curved surface at the rate of rupees 210 per 100 meter square. Again, we are making a cone. To know the dimensions first, and then we will solve, so that we do not make any mistake. This is slant height is, this is slant height L, this is H, this is R. So what is given? Slant height is 25. This is 25 meter, and diameter of base, this R is equal to D by 2 is equal to 14 by 2 meter. Okay. Find the cost of whitewashing its curved surface. So we are interested in knowing the CSA. CSA is to be painted. So this is pi RL. So 22 upon 7 into R, 14 by 2 into L, 25, 7 to here. So this will be 550 meter square. So this is 55. CSA is, upon solving, we get CSA as 550 meters square. Now we need to whitewash this area if the rate of whitewashing is rupees 210 per 100 meter square. So what is this rate? This is rupees 210 divided by 100 per meter square. For 1 meter square, we need to spend rupees 210 divided by 100. So for this meter square, so cost will be 550 into 210 divided by 100. So 55 into 21, that is 1155. This is the sixth problem. Now coming to the seventh problem of exercise 13.3. A joker's cap is in the form of a right circular cone of base radius 7 cm, height 24 cm. Find the area of the sheet required to make 10 such caps. Again, the cone dimension we are writing cone base radius. This R is given as 7 cm. Okay. Height, this H is given as 24 cm. Okay. And we need to make 10 such caps. So when H is given, R is given, this L is not given. And in all the formulas, R and L are important. So we need to find out this L first. L is equal to under root H square plus R square, that is under root 24 square plus 7 square, and we get this as 24 square is 576 plus 49, and this is 625, and this is 25 cm. So L we now know. L is now 24 cm. So L we know. Now we need to make. Now first we found out the missing part. L was not there. So first we calculated L, and now coming to the other things of the question. We need to make this cap. So what is the CSA? CSA will be pi RL. So 22 upon 7 into R 7 into L 25. So 25 into 22, that is 550 centimeter square. So this area, this curved surface area, we need to make this cap. Now that the sheet from which this cap is being made should have this much of area, and we need to make 10 such caps. So for making 10 such caps, 10 caps, we require 550 into 10, that is 5500 centimeter square area. So this is the area of the sheet required to make the 10 such caps. This is about the 7th problem. Now coming to the 8th and the last problem of this exercise 13.3. A bus stop is barricaded from the remaining part of the road by using 50 hollow cones made of recycled cardboard. Each cone has a base diameter of 40 cm and height 1 meter. If the outer side of each of the cone is to be painted and the cost of painting is rupees 12 per meter square, what will be the cost of painting all these cones? Use pi is equal to 3.14 and take under root 1.04 as 1.02. This is given in the question. So, all of us have seen a structure like this standing on, being kept on roads to prevent traffic from going in a particular way. These cones are to be made. These cones are to be made. And what is given about this cone? It is given that 50 such cones are to be made and each cone has a base diameter. So this is R. R is equal to diameter divided by 2. 50 divided by each cone has a base diameter of 40 divided by 2 centimeter. Each cone has a base diameter of 40 centimeter, height 1 meter. This is H is equal to 1 meter. Okay, H is 1 meter. The outer side means the curved surface area is to be painted. Painting cost is given as rupees 12 per meter square. So here also R is given, H is given, L is not given. So first thing to find out is to find out the value of L. So we know that, and then the other thing is that this is in centimeter, this is in meter. So we need to bring all the things in one unit. So here also the rate is in meter square. So it is better that I convert everything to meter. So this is 20 centimeters. So this is 0.2 meter. So this is 0.2 meter. So what is L? L is underscore H square plus R square. So underscore H square plus R square. What is H? 1 square plus R square. This is 0.2 square. So this is under root 1 plus 0.04. This is 0.2 into 0.2. So 2 into 2, 4. And when 0.2 into 0.2, we need to put decimal point after. We need to have decimal 2 point. We need when 0.2. This is 0.2 into 0.2. So 2 and 2, 4. And we need to put decimal in second place. So this is 0.4. Okay. So this is under root 1.04. In question it is given that under root 1.04 is 1.02. So this is 1.02 meter. So now L we know 1.02 meter. So now we know the value of, this is R is equal to 0.2. Okay. So now we know this. Now we need to find out the CSA. This is what? Pi RL. So we, as per question, we have to take pi as 3.14 into R 0.2 into L 1.02. So upon multiplying, we will get this area as 0.64056 meter square. And this is the area of the outer surface, that is curved surface. So we need to make 50 such cones. So area of 50 cone, this is area of one cone. So area of 50 cone is 50 into 0.64056 meter square. Okay. So now the cost of 1 meter. So this much area of material is required to make that 50, these 50 cones, and the material comes at rupees 12 per meter square. So we need to multiply this thing with 12. So the amount would be amount required will be this 12 into 50 into 0.64056, and this amount I am writing above also, so that you may not have problem in seeing this. So the required amount is 12 into 50 into that area 64056, and this will come as, upon multiplying we will get 384.336 rupees. So this is the required solution of 8th problem, and this is all about 13.1.